Hey everyone, this is Reuben with the ESET 442 Emerging Technology Final Project, and my topic is electric transportation. So for an overview of the technology, here are some high-level industry statistics on electric vehicles. So the average usable battery bank is 60.4 kilowatt hours. That's different than the full size of the battery bank, but manufacturers put in a limit because of depth of discharge characteristics. The average range is 316 kilometers, and they discharge on average at 200 watt hours per kilometer. It takes about 8 hours or less to fully charge the usable battery, and it recovers about 30 to 45 kilometers per hour at a level 2 charger like you'd find along the highways. They also have some good towing capacity because the motors are fairly torquey, and they've got great top speed and acceleration characteristics. So over time, the range on average is trending upwards for electric vehicles, and this is typical um, of the technologies as it gets more developed. EVs also have a potential for energy storage because, 60 kilowatt hours per car, that's fairly substantial. So some of the applications that are coming out include vehicle to load, so where you can plug in 110 volt appliances to your vehicles. Here's an example with the Ioniq 5, which is a product by Hyundai, a new EV that's come out. Here's an example of some remote work. It's also got camping applications if you wanted to power your campsite. A couple appliances make it pretty much glamping at that point. And then Ford has a product that is installed in the bed of its trucks. Ford has a new F-150 Lightning coming out, which is an electric truck, one of the first to hit the market this spring in 2022. It'll even run 240 volts out of the back. And simultaneously, you can use 7.2 kilowatts, which is very substantial. A whole construction crew could potentially, frame a house in this example. Here's the Ioniq Q5 again, actually charging another EV with its own vehicle to load capabilities. There's also vehicle to grid, which is bidirectional charging, which has some interesting applications for renewable energy storage. This is an example proposed by Nissan and applied to the Nissan Leaf. The Quasar wall box won the Best in Show award at CES, the Consumer Electronics Show, back in 2020. And it's one of the early bidirectional chargers to hit the market. It also looks like the automakers are going to release their own bidirectional charging products. Here's an example of one for Ford and the F-150 Lightning again. And they've actually partnered with Sunrun to make those installations happen because there's some requirements. You need an 80 amp service to your house, which is just dedicated to the EV line itself, which is quite a bit because sometimes the whole house is only a 100 amp service. And then the way it works is that if the power is disconnected from the grid, then a transfer switch disconnects the home fully, and then you can use the power from the truck to power a house up to 3 days, which is quite a bit. The size of the battery bank on the F-150 Lightning is very substantial. So it will connect right into the panel at your house, and then they require installation by their partner Sunrun. And Sunrun doesn't really have full pricing available yet, but they're planning to release it because installations are scheduled to begin this spring. Renewable energy storage through EVs seems like a possibility because, as we talked about in class, 95% of the time a car exists in its life, it's actually parked, it's idle. And the time it's parked, if you have like a typical 9 to 5 job, it's parked while you're at work. That corresponds really well with the solar resource throughout a day. And then there's forecasts about how many EVs are going to be on the market by, as of 2020, it was, around 5 million, but towards 2030, it's approaching 300 million, according to net zero targets to reach our goals by 2050. So what would that look like in terms of renewable energy storage in 2030? If you use the battery bank on average from cars today, and then the quantity of EVs forecast for 2030, which is 300 million, you multiply that out, that's 18 terawatts of potential energy storage. But that's actually pretty insignificant when you look at forecasted global generation for photovoltaic, which is estimated at 7,000 terawatts by 2030. And these are both global figures, so that's only 0.25%. So EV storage, well, it seems like a great idea, and I think it is a great idea. It's probably only part of the solution for renewable energy storage. So what's the likelihood that EVs really take off in the future? Well, you can kind of estimate it based on how the market values things. Tesla has been really off to the races lately. For a long time, you can see that people were a little unsure, and then around 2020, maybe a switch flipped, and now that is one of the most valuable companies in the world, and I think Elon Musk is now the richest man in the world. And then if you are wanting to look at the EV market more broadly as it's valued on the stock exchanges, you can look at something like KARS available on the New York Stock Exchange. And you can see here, even since 2019, the valuations for EV and EV components seem to be climbing upwards. In terms of just volume of cars, when the Model 3 was available for pre-order, 500,000 pre-orders went in. So the car wasn't even ready yet for delivery, but 500,000 people put money down to make that, to put their name on the list for delivery. And now the Ford Lightning, as of December 2021, has 200,000 pre-orders, and that's due for delivery in spring of 2022. But they're only making 15,000 this year, so it looks like the pre-orders will not be fulfilled at least until 2023 or beyond. So in terms of what it would actually cost to get some of these vehicles, the Ford Lightning is comparable to the Tesla Model 3. It's a little more expensive, but it's different because it's the first electric truck, commercially available on the markets if it happens the way it's supposed to in spring of 2022, which is an interesting development. For a more economical option, the Chevy Bolt EV is under 40,000, and it has a really good value in terms of the range per dollar. Sometimes that's how you want to think about the bang for the buck that you're getting in terms of the EV you're buying. How far can you go for the amount of money you spend? So in conclusion, the market is growing. Valuations for the companies that are in the market are high, and there's good potential for use as energy storage or for powering loads or even backing up a whole house system instead of getting a big battery bank. Thank you.